Yes, we're in November, but that doesn't prevent us from traveling in time and relative dimension and space, which means this week we speak with Keith Hoodlet, our former host, about managing security teams and security initiatives. In the news segment, China's hacking contest turns months of effort into 15 minutes of exploits. Project Zero turns 104 days of GitHub Actions into a disclosure. Space systems turn software constellations. CVE naming turns into wibbly wobbly timey wimey stuff, and more. Check your flux capacitors and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome to Application Security Weekly. This is episode 129, recorded November 9th, 2020. I'm your host, Mike Shima, and I'm here with Matt Alderman. Hello, Matt.
Good morning. I think the Chinese hacked my Windows 10 machine, which is why I had so many issues with my camera this morning.
Oh dear. Good thing that you're keeping it patched, though. That's what we always say. And we always say hello to John Kinsella, who's with us as well. Hello, John.
Windows machines are patched, but I'm missing Flash so much.
Sorry, you broke me. I don't have a good comeback for that. I just don't miss Flash.
I bet that's what broke my camera. Removing Flash did something to the camera driver. I'm just saying.
Just saying, it is suspicious. We killed it last episode, and this episode just not, we're off the rails already. But speaking of things that are on the rails, we do have some announcements. For example, in our upcoming webcasts and technical trainings, you will learn why you should stop trying to discover unclassified data, how to thwart attackers using deception, and how to build a risk-based vulnerability management program. Visit securityweekly.com/webcasts to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. Would you like to have all of your favorite Security Weekly content at your fingertips? Do you want to hear from Sam and Andrea when we have upcoming webcasts and technical trainings? Have a question for one of our illustrious hosts, someone from the Security Weekly team, or wish you could hang out with the Security Weekly crew and community? Subscribe on your favorite podcast catcher, sign up for our mailing list, and join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. And with a bit of a mind flip and into a time slip, we're going to begin with the news this week. And we have some news about money. Let's start with that. That's always, I think, an interesting thing that gets Matt's attention. And we have kind of a pair of articles here. One is about a Chinese hacking competition, and also from Dark Reading, some insights on bug bounty. But starting off about this hacking competition, which is sort of like the Pwn to Own, hosted in China. It was pretty interesting because it awarded, about $1.2 million to a handful of teams that had up to 15 minutes to demonstrate their exploits. And I think the one thing that I always try to say here is that 15 minutes of exploits represents a large team working together and several months to get up to that point. So a team earning $750,000 almost. I would really love to know how that distributes over an hourly rate, for example.
Yeah, it sounds shocking at first, but and I mean, it's got to be. The photo on that article looks like it shows these guys up on stage. So I don't know if there was like people watching them do this. If it's like a spectator sport, like e-gaming. I mean, that's got to be sort of shocking to like see this device which everyone considers secure, and suddenly like some kid comes along and bang, it's popped. But yeah, it takes a lot more goes on behind the scenes.
Indeed, it does. And the other thing that stood out to me is that there were, unpatched vulns. So these were 0 days across a wide range of software. So you got personal systems, so iOS and browsers, for example. Business systems, which you could still call browsers on that, or business apps, I'm saying. But also, we got rid of Flash, but Adobe PDF Reader is still out there. Also, some app foundations like Docker and QEMU, and even network devices, so some router firmware. So it's not like this was all browsers all the time, or just an iOS and Android show. These were 0 days across pretty much all the software you're going to run into, whether you're on your personal device or a business device.
Yeah, I mean, I can rattle these off, right? I have an Asus wireless mesh in the house, brand new upgrade, and I'm pushing the firmware to do even more, and it got hacked. Okay, so that's out. Let's see. I got the Windows 10 machine. My camera wasn't working this morning, so that was the April 2020 edition, but I'm pretty sure this thing got updated last week after the webcast, so that's now toast. I am running my iPhone. It's sitting right next to me, right? So I got the phone, so that's toast. Let's see, I run a Chrome browser. Luckily, I'm not running any Docker or VMware right now, but yeah, I'm pretty hosed.
I bet between the three of us, the only thing we're not running is VMware.
Probably.
That's possibly true.
Well, don't look at us to be the experts. So long.
Yep. That was a short episode. We got time to go patch. Sorry, folks. But while John and I go and update our systems, Matt, you pointed out another one. Here's sort of an article about bug hunting tips, and this one stood out for you. It's a good tie-in to this.
Yeah, it did. As I go through the news articles, usually over the weekend, because I'm pulling my articles for Business Security Weekly after this, I always run across a couple articles that I think are interesting for this show. So I'm like, oh, here's one. Here's the tips on how to go after bug bounties. And what I thought was interesting is they're trying to educate people here a little bit to say, be selective if you want to get into this bug bounty game, right? There's a lot of different programs. Don't chase the money. It gives you some really interesting tips. I mean, you see this large payout in China. They did, I think, 1.2 million total. The top team, almost $750,000 in payouts. So people are like, ooh, I want to become a bug bounty hunter and go out and hack these applications. It's just an interesting article for people to read to say, all right, if I'm going to do this, how should I approach it? Because there's some really great tips in here about, look, don't chase the money. Pick one of the programs that you're comfortable with that maybe has impact for you or your organization and kind of stick with it for a while. Learn the right tools and techniques. So I thought it was a really good article that paired this whole Chinese hacking program.
Yeah, I think it does. And it's definitely one of those things that gives a little bit more realism to what to expect out of bug bounty programs. You can get lucky and out of the gate find something really consequential and impactful and make a fair bit of coin off it. But on the other hand, you're also competing with quite a few people. And so every time you show up and get that duplicate because somebody reported that vuln first, that's not great for your own hourly rate, for example. But to your point about find an area that you're familiar with or find a type of vulnerability to go after. One of the things that the Google Project Zero goes after is a lot of the infrastructure and applications that people use or that organizations use on a daily basis. And now quite a bit of it falls into that of smartphones, browsers, of course. And in this case, they got some GitHub Actions. And there were a couple things that stood out to me, but one in particular was that GitHub Actions, they have their own hardening recommendations about how you should go about dealing with this type of capability. But Actions are basically a way to say, here are some events that are happening during your build process on GitHub. And it's pretty much watching the standard out of log messages to say, there's something that I need to go trigger on. There's an event that I need to go do. And this particular write-up was being a bit pessimistic on whether or not GitHub Actions could even be securable in an effective manner. And so I thought that was a pretty interesting thing to think about.
What I like about this article is two things. Number one, it ties to the previous article. The last tip that it gives you is go after a program that has a vulnerability disclosure program, maybe not even a payout. Yeah. Just go after a place where you can do vulnerability disclosure program, because then you don't get in trouble for trying to go hack a site. So here you take Project Zero, right? Google's project that goes out, identifies this vulnerability, and GitHub, now owned by Microsoft, has a vulnerability disclosure program, and they're like, hey, it's been 104 days, enough is enough. So I thought that was a really interesting first piece of this, is because they get a little snarky with Microsoft and GitHub here to say, look, you've had 104 days to fix this thing. I only had to give you 90. You've asked for an extension. My response is basically no. But then they get into the details, and Mike, they point out, look, the way these things are implemented is just inherently insecure. There may not be a fix for this.
Yeah, I think that's a good point. And I'm not saying, so it comes back a little bit to security theater, at least kind of in the spirit of it. Now, I'm not saying that there's security theater here with what GitHub is doing, but it's more the idea of, did we build something and have security controls around it that actually work the way we expected them to, or can they even work in the way we want them to? And if not, then maybe we got to step back, like you're saying, and reevaluate whether this GitHub Actions or this type of capability is something we actually want to expose in the first place.
Yeah, and it could require a complete rewrite of these actions. Or what I think the article is kind of saying is, look, they're going to gradually just remove them because they're not quite sure how they're going to secure them.
It's sort of interesting, right? Because, I mean, think about it from AppSec. If we went through one of the areas which probably gets the least amount of attention, it's sanitizing logs for any application, right? So the line in here which got me when I saw this is, unless you trust the output from whatever that build program is. In other words, you basically got untrusted output coming from the compiler or the build or whatever that build step is. You're looking at these logs and parsing them. So if you can't trust that, how does GitHub then provide tools which are, I'll say, defensive, are able to work in that offensive environment? So it's something, we usually don't think about putting lots of good details and useful information into build logs. I mean, how many years that we've been complaining about, compiler errors and like syntax errors and stuff like that, and what do they mean? So you got that environment plus an environment where people don't think about actually cleaning things. So, it's a mixture of things.
It's definitely a mixture of things. There's another tough part is they acknowledge that you're going to need secrets in order to make a lot of these actions actually useful so that they can talk to other potentially credentialed services. And they say we have a way to redact the secrets, but technically we can only redact the secrets if you give them to us raw. If you accidentally put them into structured data, in a JSON blob or something like that, we may miss that secret, and it's going to get printed out to your log statement. And just as John was saying, now we have exposed, something that, as the name implies, should have remained secret. So there's definitely a lot of gotchas in here. So it's just one of those trade-offs. How much do we enable better and more efficient engineering at the expense of a lot of really easy mistakes to make potentially that are pretty consequential from a security perspective? I think this, too, gives us talking about Vulns. There's another article that you highlighted, Matt, about containers in high-performance computing, but containers and the first time I read through this article, the median amount of vulnerabilities were found was just over 300, and that made me a little bit skeptical or trying to figure out what the heck is going on inside them.
Yeah, we've talked about this in various aspects before. We know that a lot of the open source components that we embed into our software, and sometimes we don't know it because they're kind of include statements from the container image, introduces a lot of potential vulnerabilities. What I thought was interesting here is they evaluated this on the research side for this high performance computing environment and found a lot of pretty interesting kind of results, right? One image had 1,700 vulnerabilities, where some of them had none, right? And so we've talked about this supply chain, this dependency chain of all this software that gets included in these container images, and the potential concern. The median was 321 vulnerabilities. What are they using? Are these things that we're using commonly and are there, or are these very specific types of open source software components that are just for this environment, and therefore they're more risky because nobody's looking at them at the same depth? I just thought it was some interesting research.
Yeah, I think the take-home message for me there was they point out like Alpine Linux pretty much had no vulns, basically because it also had very few software packages on it that were introducing these dependency problems. And that's these dependency. If you basically just updated the container, I think they said 2/3 of the vulns just go away automatically. So there's a little bit of the aspect of, have you installed more packages than you actually needed on these containers? Or have you just pulled down the containers but not bothered to update them, and you're dealing with older systems? So a lot of it comes back to the idea of patch your systems, which I also kind of think plays into that aspect of patching, as well as our initial conversation about vulnerabilities can be expensive. I pulled out a pair of articles that were about kind of post-compromise scenarios because I wanted to talk a little bit about the threat modeling from that perspective. But one thing that caught my eye, there was from Mandiant, FireEye, talking about a 0-day that was purchased on the dark market for $3,000. So this is they're tying things together, but in a Oracle Solaris SSHD remote root exploit, $3,000. So this was something that I wanted to highlight this in the sense of, you don't necessarily need that super expensive modern 0-day for Chrome or Safari, iOS, Android. Go with the exploit that works. In this case, that's actually pretty cheap. And then the write-up explains, all of the different steps that were taken once this initial compromise happened.
Well, I think the reason it was only $3,000 is because this was for Solaris. How many people are still running these systems?
Yeah, exactly. It was more of a, we feel bad for you. Buy your administrators something nice for Christmas. But I think this one and the other article about an initial vector was a PHP vulnerability. But I did want to highlight them because it comes into that aspect of not necessarily just that initial vulnerability, but also look at what attackers are doing. And in whether it's your cloud environment, your AWS environment, how many restrictions do you have in a post-compromise scenario? Meaning, avoiding things like lateral movement. In the FireEye case, that blog post was pretty nice because they had a good list of the MITRE attack tactic categories near there at the end to kind of help you talk through with your DevOps team about what would our kill chain look like if our front-end web server were compromised, or our SSHD Oracle or Solaris Bastion host was compromised. What could happen from there? So there's takeaway messages you could figure out of, can we have multi-factor authentication? Because that would defeat a lot of the raw credential logging that was part of this backdoor, and other types of scenarios you might come up with.
I sort of wonder if PHP is next Flash. In other
Possibly.
words, is that the one? I mean, it's lasted about 10 years longer than I thought it would. I was using PHP in the 90s. Come on now.
Now,
yeah. I don't know. There's a lot of systems out there running PHP. I mean, as bad as it is, guys, right? I mean, you really think we're going to get rid of PHP anytime soon?
Look, to his credit, PHP hasn't tried to go from a server-side language to a client-side language, unlike perhaps JavaScript, which jumped from our browser to server. So it could be worse. But
I used to work with... Just a real quick comment on that. I used to work with someone who Troy, if you're out there somewhere, hope you're doing well. He would actually write his cron jobs in PHP.
Brave man. But in this case, I did, speaking of PHP, and not necessarily to unduly pick on the language, but part of the write-up was pretty interesting, and both these write-ups are really nice for the level of detail they have. And the initial problem here in this web app was that it had a type confusion. So in PHP, you could actually give a password parameter, essentially turn it into an array. And then on the server side, it would expect, rather than a string literal, it would say, oh, I've just received an array. And that type confusion in a comparison statement would mess things up. The other thing that was weird, and actually the reason I'm setting that up is that that's possibly the type of thing that a linter or some type of SaaS tool should ideally find. But there was also something a bit weird about that setup, in that the application would set up your session, then it would verify if your password is correct. And if it was bad, it was the wrong password, it would destroy the session. And if it was correct, it would let you go on forward. But that was a little bit wonky in the sense of, why not verify the password first, then allow the session to set up and then go forward? And that's not the type of thing that a SaaS tool or some other type of automated checker is very likely to find. So I just thought that was a really interesting aspect of two different sides of a flaw that a tool should be able to find, but also a flaw that you should engage your AppSec team, your product security team, and do some human analysis to discover.
Yeah, I think the initial attack vector on this one was a authentication bypass, right? To your point, right? You let the session come up before you validated authentication, which allowed this second kind of phase to flow. Again, we talk about authentication. It's getting so much more complex these days, but it is a very effective attack vector in some of these attacks.
It's probably becoming more so since, as we go towards more cloud type things. I think 2021 is going to be really interesting to look at, of all these different sort of mesh networks coming out, like security networks that will, I'm missing the buzzwords right now, sorry, but sort of different types of VPNs to allow better control over what you can do with that access. I guess you could call it zero access, but I think that's hopefully going to help with a lot of this.
Well, you got service mesh and SASE and zero trust and ML and AI, and we'll throw out a few more buzz terms and we'll get
Yeah, SASE is the one I was thinking of, but well, I mean, because otherwise it seems like we've taken a step back, right, over the last year or two. I mean, the OAuth and those type of things should be helping and should be allowed to control it, but it seems like this is not going to go away pretty soon.
No, not going to go away. And I think those are, in the spirit of, we do try to find articles that can educate and be relevant to systems. So even if you're not running PHP, I think set aside that initial injection flaw and just say, okay, your front end gets popped, and here are all the bad things that could fall out to happen. Those are pretty much the same exercises you can go through, regardless of what cloud environment you're on, regardless of what container strategy you've taken. So I think these are really good ways to do what's called sort of a pre-mortem, if you will, and just model, how could this happen to us and what would we do about it? One of the other things that we've got one article I'm saving for the end because I think it's going to be fun, but I want to go to space first. And John, you actually, I think, highlighted this one. You've been following a fabulous acronym, by the way, the Aerospace Safety Advisory Panel, or NASA's ASAP. Talking about software quality. What stood out to you for this one?
Come on, isn't space fun? Yeah, this was. So this is, let me bring it up so I can talk to it a little more accurately. But this is really around, NASA's getting ready to launch this new rocket up to the moon here pretty soon. And with most things governments run in the last decade or two, there's all these different sort of subcontractors which are involved in actually putting this thing together. It turns out they're doing a little bit, probably too much of the rush with this guy, because what's actually happening is, as we're more and more software based, all these different vendors and subcontractors are doing something which is software based, expected to tie into the bigger software behemoth when this thing goes up onto 39A or whichever launch pad it's going to. But they're not doing too much of the integrated testing between those pieces before they get up on that launch pad. So the government organization, the Accountability Office, is sort of saying, hey, we're a little worried about this. And that sounds like it might be sort of fair. This is something which probably come together and there'll be no problem. Hopefully, knock on wood and all that. But at the same time, it's again, one of those examples when I look at the space stuff and bring it on here, it's very large organizations having sort of the same problem that we talk about in the smaller ends are the more, standard large enterprises. It even hits the really big guys.
Absolutely. And very much, this is an exceedingly great example of a consequence-driven cyber-informed engineering, the CCE that we were talking about in IoT, industrial IoT, a couple of weeks ago. And I went in because I was feeling bored and it was unexciting. I went and read through some of the meeting minutes of one of their recent public meetings that was posted, and there were a couple things that stood out that sound just like you were saying could apply to organizations large and small. One was, they were saying as the problem, there's no end-to-end integrated, in this case avionics, but software integration capability. So they had multiple labs, emulators, and simulations being used to test subsets of the software, but not really understanding how they all fit together. And there was a great quote that could be, I think, applied to DevOps teams, SREs, security. They were saying flight systems should be developed for success with the goal to test like you fly in the same way that NASA's operations team train the way you fly the way you train. And I think you could really swap out the words there about, build the software, secure the software, test the software, build the software, what have you, and just really good ideas to follow.
It's sort of surprising, I guess, because, I think of I'm sure it's on here, and folks have heard me from years quote about the old article. I think it was in Fortune, The Right Stuff, talking about the space shuttle and how careful they were. So to see the opposite of that happening here is, and also kudos to you, man, for actually going and reading those meeting minutes. That had to have been sort of torture.
It was in a very geeky way. It was actually kind of fun and interesting. So, and I will have to now, because time is fleeting, madness takes its toll, I'm going to have to segue into our last article of the day, which is from from CERT, about launching what they're calling the Vulnonym, because they want to stop the naming madness. Now, their premise is that some vulnerabilities like Shell Shock and others are becoming overhyped, overblown, and really, really sound scary. But if you go the opposite end of the spectrum, nobody knows CVE numbers. CVE 2020-12345. Who knows what that even stands for? And it's really hard to reference them. So,
but Mike, we used to memorize the numbers.
We did. When there were fewer numbers in a year. I think, when you could have less than maybe 1,000, even less than 100 in a year, maybe it was a little bit easier.
I think if they're popular ones, I think we still do. I think 169 from 2018 was one of the Docker exploits, which we used to do a POC for. So I think, I don't know. I think there's still some value, and at least to me, the numbers are a lot easier to keep track of than one of my comments in this article was, it reminds me of Ubuntu and Debian over the last, decade or so. I can't keep track of what version of Debian is if you tell me it's trusty, jumper, whatever the hell. That stuff goes straight through my head. So at least to me, the numbers seem to be a little more logical.
Yeah, you do have a valid point, Mike. We do have way more CVE numbers now than we've ever had. So I get it. But there are ones that kind of stick in the back of our heads like, yeah, we know that one, right? But the article, I love this article because, look, we've been hyping these vulnerabilities, right, for a while with these different naming conventions. What they're trying to do is kind of level set this a little bit, I think. We'll see how well this works, though.
Yeah, and I think, to your point, though, CVE numbers translate pretty well, where if we start going with, the naming, everything goes into English words. And if you go check out the Vulnonym Twitter feed, a lot of those words that the pairs that they're coming up with are even maybe a little bit questionable. Is this actually English, or this is a bit obscure? And now, from my perspective, I love this idea of pairing up words. It's great for code names. It's great for your incident response investigations. situations when you don't want to actually leak information about a subject and you're trying to get rid of context. But I would argue that even with the names that people come up with branding, they carry a little bit of context that can be helpful. And I will stand firmly in the ground that all Bluetooth vulnerabilities must actually start with the word, that has BL in the very beginning, because otherwise I'll be very disappointed.
Right. I mean, you could almost do that with a bunch of them, right? You could have, like, if this is a Windows vulnerability, it always has this part of a name in it, right? I mean, okay, then we'd all remember that that's the Windows one versus the Bluetooth one versus the this, that, or the other thing. Again, we'll see how this works. But look, marketing teams will always do their best to find a name that they can wrap all their FUD around.
I think you're right. And go ahead, John.
Sorry, quickly. I'm reading through this Twitter list, which is sort of fun, and I'm thinking about the next RSA, whether that's 2021, 2022, whenever. But I'm looking forward to seeing the marketing it boosts for dismissive mammal and / partridge and twisting nartica. So I'm really looking forward to seeing big boost with something like that.
Exactly. That's going to be the startup alley for all of the security company names. But I think one of the things, Matt, you were definitely going down the road of marketing teams and getting too much FUD, and that's definitely a problem to identify with the overhyped branding. And we have seen that with I can't remember which of that. It was one of the SMB exploits. I want to say 5 or 6 years ago. But there's also, and another reason I wanted to pull this out, there's also a problem here, or a challenge here, to go after messaging. How do you do security communication? And this, we're talking with vulnerability naming at very much the grand stage, but this communicating security is also on a small scale a security team talking to a DevOps team. We're talking within an organization, and it's the idea of, are you just rattling off CVE numbers that people remember, that they recognize, or they know this is something to deal with? And I also wanted to pull out a little bit of a parallel here with when articles talk about CVSS numbers. For example, scoring the perfect 10 on a CVSS. What does that really mean? Because it's not really a perfect 10. It just means that's a critical vulnerability. Sort of the same thing of, do we really care about the difference between a CVSS 9.6 and a 9.7? What does that decimal point actually really mean, other than we should just go and fix something? So the naming, the scores, they do lose a lot of context. I don't have a good idea right now exactly what are the succinct ways to pull that context back in.
Yeah, but I mean, we did a webcast on metrics and KPIs and stuff last week with Deepwatch, and we talked a little bit about the language and how you communicate. If we're communicating at CVE levels, at certain levels of the organization, we're missing the mark holistically, right? So I think communication depends on which audience, right? Maybe with the DevOps teams, we need to be a little more granular in the vulnerability, the aspects of the vulnerabilities, maybe the CVE number, the score, or aspects of it. But if we're having that conversation at the executive level or the board level, we are missing the boat big time.
That's a fantastic point. Who's the audience? Yeah, that makes a huge difference. So, that seems like such a great thing to end on. But I did want to say, before we do end, maybe we could also set up a security weekly, name vulnerability naming generator, and each of us could pick one word, and that's just how we go and name them. So, John, you already were looking them up, so you get the first attack at the next CVE that comes out in our next episode we cover.
I'm looking at snow, so I'll say snowy.
Snowy sounds good. We'll throw it over to Matt for the second word, and that's what we have for our next CVE.
It's cloudy out, so
snowy clouds. There we go. Everybody go and patch your snowy cloud, because that's what the vulnerability of the week is.
And hey, we may not be that far off. There might be some cloud service with snow in it that Amazon just released and it has a vulnerability, so we might actually be close.
There we go. Yeah. So what is it? Life imitates art. There we are. Well, I think, speaking of knowing our audience, I think it's also important to know that who to thank. And we want to thank you all for joining us to listen. I also want to thank Matt and John once again. We do have our interview coming up with Keith, and it's a pre-recorded interview. So that's why, mysteriously, Matt is going to disappear. But of course, we always love having Matt with us. So give us a moment to take a quick regeneration and return for our interview with Keith.